7 is open. If you guys hadn't seen that yet, a bunch of you did notice 7 is open. So I'll refer you to your calendar schedule thing that I handed out that you can be working through on there. Should be good to go. Brian's working on it. He's getting close, and I got to show you something there. I did go back into AC 43. If I go to 11.158, that must be paragraph, I think. I hope I wrote it down right. 11. Where am I at? Come on, bring it up. I should have bookmarked it. I highlighted it once we get there. 11.158, talking about cable ties. All right, there we go. Corbin noticed, somehow I ended up with, I think, Australian regs. And I was like, oh, that's weird. How did I get there? So we got very similar if we go to the US AC 43. In lieu of applying ties, straps, meeting specification, blah, blah, blah. So there's a little bit of, they give you some different ties. I actually stumbled across the US Navy is trying to totally get rid of cable ties, zip ties. I was going to show you the whole article, but it's long and boring and you guys don't work for the Navy. Sorry, babe. But they're talking about how they are fairly common to break and fall off and even causing FOD because they fall to foreign object debris, right? They fall down in places where they shouldn't be. So they've got some new style, but trying to push everybody towards lacing and say you can't use it. But temperatures do not exceed 120. They're getting some new ones. But they may not be used in high vibration areas where failure of strap would permit wiring to move against parts, which could damage insulation, foul mechanical linkages, or other moving mechanical devices. They also may not be used where they could be exposed to UV light unless straps are resistant. So if you get into the black ones, you get into a similar thing where you're like, well, we maybe made an exception for it. But basically that reads pretty close to the same as my Australian one. And while I'm in the neighborhood, 11.146 talks about whether it's your lacing or whatever. Man, it's funny how sometimes you can't see it and sometimes it's really good. It's talking about clamps. They should be spaced at intervals not exceeding 24 inches. So we don't want to ever have a run that's more than 24 that's not secure. I would recommend, if you get a chance in the lab, reading basically this section. It's like page 1157. And do a read through. It gives you a really great overview. It's what we're teaching. Most of it will be review, but you can scan through it pretty quick. It's about 8 to 10 pages on electrical, and you can kind of notice all the spots I highlighted are the important stuff that we will teach once, but a lot of times if you read it for yourself, it helps it sink in and go, oh, that's not just some case said, it's actually in there. So, how you doing over there? Done? Excellent. Okay. Wanted to show you, and Dean might have pointed out to some of you already, I had them, I don't even think it hits today's lesson, I believe it heads into a day or two from now, but these fancy spoons that he would pick up from the airlines, and man, these are handy. What they're handiest for is, let's say you've got a bundle of wire, and you need to add a wire to it. So maybe you're an avionics guy, and you're back behind the cockpit, and there's a bunch of wires, and you're going, you know, how many wire ties, because I'm going to use them in case said not to, do I really want to just keep overlapping the bundle? Am I going to put this on top of here and then add a bunch more ties? Am I going to lace over it? Do I really want to, where I can only get one hand up in there, cut all these off and try to retie it? So the alternative is to get this wire underneath there, and this one would be, you know, pretty tricky. I could work at this a bit, and I can probably get it under there. but it's not gonna be easy, and this is where I can see it. Imagine I'm doing it one-handed up in there. So they make these fancy spoons, there's some on the table, and they're pretty easy, you just slide it underneath, and sometimes you gotta push a little bit hard to give yourself room, but once you get the spoon in, oh, it's gonna make a liar out of me. Once you get the spoon in, if it's deep enough, too big a wire. You slide your wire, go, man, go. It's a good knot, Brian, it's a good knot. I'm gonna get it. You can imagine without the spoon, there's no way. There we go. You slide your wire in. Once it's started, you're pretty good. It's gonna pull through fine. So then you go to the next one, and you can move yourself down. There we go. That one's not a knot, right? These are really, really handy. I don't have one in my tool bag, but it's on my to-do list because, man, save a lot. The other nice part about that is when we're cutting those off, very easy to damage the insulation by putting our cutters in there, nicking wires if you're using the razor blade. So whether you're using the razor blade or your cutters, if you put a spoon under there, all of a sudden, oh man, there's no chance I'm gonna damage the wire because I'm cutting inside my metal groove. So, I'm gonna say, even well not even I am continually learning stuff. That seems like a very, very valuable tool. So make sure you get one. They can't be expensive either, can they? This is pretty nice. I am going to, when we first start lab, we'll do the generator test out there. If nobody's around, I'll do it by myself. But if you haven't seen a successful generator test, probably would be a good idea to peek on that. If you test a generator on your, on your P's, it's nice to be like, yeah, that is what it's supposed to look like, instead of, well, mine was bad, so when I did this in class, it kind of worked. So I'm going to do that when we go out there if you haven't seen it yet. All right, that is all my house cleaning stuff. We can get into our lecture. Mostly what we're going to be talking about today is our wire termination. And no, I don't mean destroying the end of our wires, not like the Terminator, but how we finish off the end of the wire. This is a really important part that I highlighted. The tensile strength of the wire to terminal joint should be at least equivalent to the tensile strength of the wire itself, and its resistance negligible relative to the normal resistance of the wire. So obviously we don't want the electrical resistance to be higher and build up heat at that. But the big part with saying it should be as strong is when you make a connection and I come over to your board and I say, is that tight? If I can pull that wire connector off, well, theoretically your termination is not as strong. Now you get into kind of a gray area when you say tensile strength, is it this way or sideways? But they should be crimped down on there so they are tight, tight, tight. So if I come up to it, I am not like pulling as hard as I can, but if I can just grab it and pull the thing off the end, it was not tight enough. And we're going to cover today how to make sure that we are making good connections, because just getting a crimper that you're going to gorilla down on there is not the solution. Putting the right one on is the solution. Soldering. In your book, it's 11.01.24, and when we solder something, we heat up the wire, we heat up the solder, we goob a bunch on there, and we might think that when we're soldering it on, I think this one shows kind of a soldered connection, hard to see, but we might think that when we solder it on there, we're adding a bunch of material and that's going to make the whole goober stronger. Well, the issue is we're adding so much heat that our heat is going to heat up that wire, and especially with copper, it's most often going to weaken our wire. So that little section we heated, and then the next little bit of a section coming right out of the solder, we actually weaken our wire a little bit. So soldering is okay. Dean loves solder, and some components, like there's the back of some switches where there's like 12 connections on them. It's almost impossible to get screws on all those, so sometimes on especially small connections, especially if we're talking low voltage, well, I should say low voltage, low amperage, where we just have to have electrical flow, you know, solder can be better. I'll go that far to say it. But in general, solder weakens our wires. So we gotta be really careful about how often we solder, and that does come up to be a FAA question. So if you are making a splice, which we'll talk about later, you might go, oh, a soldered splice is the best. Problem is, when we solder it, we heat it up, that heat weakens the wire, and it can cause issues. Basically, when we have failed connections that are soldered, typically it's not the connection that fails, it's right next to it. It's soldered, it got hard. The solders tend to be very, very rigid, right? So there's a very, very rigid spot, so any vibration and flex all gets focused right next to the solder joint on our weakened wire, and that's where they break off. A crimped connection, you'll find verbiage where the stresses of the vibration and all that stuff are supposed to be basically distributed along the whole body of the crimp. So you don't tend to have that one weak point where we end the solder and start our weakened wire. They're supposed to be distributed through that whole crimp, and that's why we tend not to have broken wires in a crimp. What we tend to have with crimps, if they're incorrect, is, oops, my crimp wasn't tight enough, which is installation error. I put a note in here, I said I shouldn't have to say this, but I will. The insulation needs to be stripped from the wire. It seems like every year we get a wire or two, and it's probably more, whoops, I forgot to strip it on that one, but somebody crimps it down without stripping the insulation. Now, there are, and a photo comes up later, there are some connectors that the metal bends around and it kind of even punctures in through the insulation. That puncture is not designed to be an electrical fitting as much as it is physically securing the insulation. That's especially on Molex connectors when we do Molex in a couple days. But we do need to remove that insulation. And then we're going to have to be very careful how we remove the insulation. Your electrician friends or heating and cooling guys often use wire strippers that look like this, and they can get away with it because when they're sizing a wire, are they going, was this wire 10 foot long or 15 foot long? No. They're going, oh, 20 amp, that's a 14 gauge, and everything in the house that's 20 amp gets run 14 gauge. So most of their wires are oversized because they're not nearly as picky as we are. And the other thing is, your house, unless you live in California, does it vibrate and shake all day long? Hopefully not. So they can get away with not being so careful on their stripping jobs. And if it's a little bit damaged, not the end of the world. Not saying it's okay to damage wires in a household or industrial application, but in aviation we need to be much more careful than the rest of the world. So here's a couple zoomed in images, and if you're old like me, you might have to really zoom in on how big the wires are. But we like them nice, tight strands with the factory twist. If we get a little bit too loose and flat, it can cause some issues when we go to crimp it. But the bigger deal is, and it's hard to see, come through perfect, but you get the idea. If you use especially those other style strippers, you'll nick a bunch of the wires in here if you're not very, very careful. Most of the strippers will cut basically all the way through the insulation. They'll nick your wire, and when you pull it off, if you don't inspect it really close, you won't notice. A perfect stripper barely cuts through the insulation, and it might not even make it all the way through, and then it pulls that insulation off. So that last little bit is, it's a borderline where it's not even cut, but it tears the insulation. on the last tiny little bit. This one, if you look close, you can see some more nicks in the copper. And you're like, wow, you're getting kind of picky, Case. And I'm like, well, we don't have a lot of extra wire. We don't have a lot of extra strands. And when you get to our connection's supposed to be as strong or stronger than the wire itself, if we lose 2 of 10 strands, we're down 20% on our strength in that thing. So we need to be really, really careful. So with that said, they want to, and AC43 even says, use the fancy aviation wire stripping tool. So these are pretty cool. I haven't gone quite so far as to buy one to put it in my tool bag that's mobile with me yet, because it's big and heavy, and I don't work on electrical wiring that much for aircraft, but these are cool. Basically what they do is on one side they've got the cutter that comes down, and that's going to cut the insulation on the wire. Labeled on there is the different size wire in AWG, so it's 14, 12, 10, 8, and then it gets back small again, 16, 18. So you got to find the right one, because obviously if I was going to put this in a, let's say, 14 gauge wire, when this is a 12 gauge wire, oops, I catch it on the backside, it's bent. 14 when it's a 12, if I do it that way, oh man, and it gets hard to do, and I actually just cut through a bunch of my copper wire, so I ruined that one. So I'm going to cut it off. These little guys will not last very long if you use them for cutting your wire. Just a warning, they're super, super handy for cutting everybody else's cable ties off, because you guys are going to lace, right? They're super, super handy for cutting everybody else's cable ties off. If you get in the habit of grabbing these guys for cutting wire, because it's nice and you can reach up in your aircraft, they're just probably not going to last. You can do it if you want, but next time you grab a cable tie to cut it off, you're going to be like, man, this thing just is not as sharp as it used to be. Same thing with this. You use it for wire too much, you start cutting, oh man, you're sitting here in front of class pulling at it instead of cutting it. So I highly recommend don't cut wire with these, because it'll just dull them a little bit. So a good pair of side cutters and an official stripper is the best way to go. So if I go back to, this was a 12, right? Should say right on the wire. Should be labeled every so many inches. Backside of my wire. And you read upside down. Put it off. Can't read 10. Oh man. I think I put it in the wrong hole. 14. I'm going to read it because I just cut. It's 12. I just cut a couple more. I don't know if I had it in the wrong strand. So even on putting on the right one, I cut a couple there. So got to be careful of that when you're doing it. But the idea is you put it in there. It's got the cutter for the insulation on this side, and the back side it actually grabs the wire, the insulation. So what it does is it's grab the wire, then cut the insulation, and then it pulls it off the end of there. I'm going to do it one more time because I'm a little bit upset that my demo with the fancy tool cut my wire off. Okay, grab, cut, strip. This might need a little maintenance. There we go. Looks better. Still nicked a few. Very interesting. I might have to look into that. So that's how they're supposed to work, and if you're really careful or you get into bigger wire, if you got a much larger size wire, you can do it with a very sharp knife around the edge. You can just cut the insulation off and work it that way. Sometimes you can do it with this. The problem is if you use a small one like this guy and try to strip your wire, or even the other one, what's going to happen often is you're going to cut through too far. So if you use a non-official one, you got to inspect it really close. I've done thousands and thousands of wires, so you get to the feeling of I don't want to go all the way through the insulation. I want to go about 3/4 of the way through, and then I can pull it the rest of the way and tear it off. Does that make sense? Cool. Terminals. A little deeper dive into the actual terminals. If it's over 10 gauge, and this will show up on questions, and you can hunt in the book for it too. But if it's over 10 gauge, you're typically not gonna have insulation on the connectors. So that means that if it's smaller than 10 gauge, insulation on it. So you say, well, what do I do with 10 gauge? Nah, it gives you a gray area. What are you feeling like today? Over 10, no insulation, 10 and under, or gray area, you're gonna have insulation on that connectors. There's not necessarily a PMA on the connectors. PMA means official aviation part number, right? But they do need to conform to the MS or military standard. And if you get hunting around and you're like, well, how do I know? It's an interesting gray area there. Basically, you can get them at Harbor Freight and put them on your airplane. If it looks like a cheap one, if it smells like a cheap one, smells not the right word. Maybe it doesn't conform to the military standard because it's too cheap. So you can source them from an actual aviation place. The more expensive, nicer ones are often stamped with a military standard number on them. But just because it does not have a PMA number on it does not mean that you're not allowed to use it. So, does that make sense? Almost everything else in aviation, if it doesn't have a part number on it, you're not going to be using it because you're like, well, I don't know if this actually meets the standard. Terminals are in that gray area for that. We want ring connections, which is this guy here. That is what we want. We are not allowed to have these forked connections. Those are not allowed. The idea is if the wire securing device, usually screw, right, bolt, nut, were to come a little bit loose, that one can pull out. And not only does that ruin the electrical connection, but now it's flopping around, and if it's the hot side, it can hit stuff. So the ring secures it in place. The other thing is when you tighten this down under a screw or under a washer, that one, the whole surface area is a uniform compression on it. If you tighten that one down under a screw or surface area, you got this whole section right here that is not compressed right. So it'll tend to try to twist your washer just ever so slightly, and you go, really, Case, is that gonna make a difference? And the thing is, in aviation, where we got vibrations and all that stuff, we don't wanna have that situation. So, the ring style, they'll call it ring tongue, they'll call it a couple different things, but ring connector is what we want. Spade, call those spades. Stake-ons is what we used to call them, and now it's eluding me this morning. I'll find it eventually. Those are allowed. You'll see it on a ton of small switches. So like your master alternator switch on the 206s, Cessnas, they almost all have this connection on the back side. And when you get out there and you get looking at them, what you'll notice is, if I was to draw it, that's probably too far. That's kind of an end view. The flat part on the bottom then goes up, and there's a bump up in the middle. That bump up in the middle is really important because if the connection is all the way in, that bump up, and I have this one on there kind of for idea, but that bump up actually will drop down into a hole to hold it in place. It's not like you don't have to use a screwdriver to get it out, but that's really important. The connection itself for the connector is a big part of it. It is made on those two pieces that run the length of the connection. So the electrical connection, a big part of the connection is actually these two that are then forced into the connector. Yes, there is connection on the back side, there's connection where the bump is in there, but the primary force or electrical surfaces are often this piece here. The reason I point that out is over time, or if they got hot, or if you had vibration, sometimes these guys can get a little bit loose, and he might get kind of where he's bent out a little bit and he's not holding as tight. If they get loose and they're not holding as tight, you're gonna wanna replace it. If it was your house, you could probably take a pliers and just crimp them back down a little bit, right? Tighten them on down and make sure it's pinching good. If it loosened up, we stress the metal. And you go, well, what stressed it? So number one, why did it loosen? It's good to figure out, is my wire not clamped? What's going on? But number two, we already stressed it, and if we put it back, and it'll probably work, but best practice is don't necessarily just crimp it back down. If we got enough wire, let's replace that and get a good connection on there. We absolutely don't want good wire connectors, bad wire connectors.
When you say smaller than 10 gauge, do you mean a smaller gauge number? Or?
You know, that is, yeah, so, smaller wire, which would be yeah. Good point. Whenever you see smaller, you're thinking wire size. If you see over wire size, where does that show up? I don't know if it's on the exam maybe. You gotta be really careful about when we start saying smaller, but yeah, pretty much in written or when you're talking, when we use smaller or larger, we're talking the diameter of the wire. We're not talking the number that it is, because it goes backwards, right? If I go to a size 24 gauge wire, it's a smaller wire, so I really go up to a 24 and down to a 24. So, yep. Hopefully, you don't ever see this guy connected to this guy out as a junction point. And the reason is any stress, any vibration will tend to pull it apart. You get into, I'm not sure if the word is gray area, but in the back of a 206, there's often, that was probably a bad drawing. Anyway, there's often a tail cone that comes off. Why is my drawing so weird? Rudder, that's what it is. The rudder's like that. So there's often a tail cone that's got to come off, that's got your light bulb in the back. And when you're doing your annual inspection, you're doing your 100-hour inspection, you got to take that thing off. Well, the wires from that go up through and they go through the aircraft. And how are we going to get that off? So it's pretty common you have to take the screws out and disconnect the electrical connectors right there. The best case scenario is you've got a Molex plug that plugs together and unplugs, and a good mechanic will typically install like a Molex plug in that area. Occasionally you'll get where mechanics have put in a connection similar to this. We do not like those ones. The ones we like are what they call a handshake, and even this, like I said, we're in a kind of gray area, but we'll see if we stumble across them out there. But the handshake, there's basically two blades that you put them in crooked. Can't do it with my hands. Maybe I'll get a picture. You put them in crooked, and then when you straighten it back out, they secure themselves together. And that way, if you pull on the wires really hard, they're not going to come apart. They stay together. Those are, the way I phrase it is they're accepted kind of in the same way these are accepted on control panels and stuff. It's a much better way to make a junction if you have to, but there's better ways. Molex plugs are better. So, all right, moving on. Did I switch the gauge? 10. No, 10. All right. On my notes, I said I'm still looking for where I found the over 10. It'll show up eventually. So hopefully on a slide it shows up at some point. Here's a couple of them that are larger than 10, which is a smaller number than 10.
That's 10 and under?
That's where the way it's phrased, it's like, you can do either one you want with that. Talk about that. crimp on the end of the lugs and splices must be installed with a high-quality ratchet-type crimping tool, spells out in AC 43. If the crimp is too deep or not enough, it may break or cut the individual strands, or it may not tighten enough to retain the wire terminal connector. So they go as far as to spell out, use a high-quality one. So you're not using your channel locks, you're not using the cheap one. I think it's actually on your tool list to buy when you come to SMAT, actually, to have one of those ratcheting ones. They're pretty cool. They do a great job. One of the big reasons that they're good and they do a good job is it puts the crimp on there in two different places. So what you'll see and what we'll look at when we're making these is it crimps the wire underneath the barrel that's in there, and then it crimps it with the insulation under the barrel as well. So crimps it on the wire and it crimps it on the insulation as well. So you are holding kind of both spots. So it's actually like a double crimping device. Now, we gotta be careful because we seem to wreck a couple of these every year because of the ratcheting function. As I come down, there's a ratcheting mechanism that will keep it from opening back up. The idea behind that is you're putting your wire connection on and you're like, yeah, I got it tight enough, and you stop, and you're not actually compressed enough. So the maker of the tools, and they figured out, you know, if we put a ratcheting mechanism in there, they have to get it far enough before they can release the tool. The only way to release it otherwise is to reach your little finger in there and hit the release button. So they do give you a release button, and I'm going to say that's primarily for if you were to crimp the wrong size connection and you're like, I can't quite get it, now what do I do? Because if you just pull this apart, you're going to be breaking the tool, and SMAT doesn't like to buy them that often. They're pretty expensive. So if you get to where you're like, I just can't get it, something's wrong, they've got the release mechanism in there, and you can release the tool that way. But it's a crimping connection that has two spots, and it crimps down. They give you a nice little indication color on there. I forget whose I was looking at the other day. It even told you the AWG size of the wire for each one. And it's like, oh, that's kind of handy. Most of ours at SMAT don't give it to you, and or they give it to you in metric, which isn't very helpful. So there are a ton of ways to crimp the wire. We will do these Molex connections in a later class. So these are made with a different style crimper. It's a specialty one. We'll do that in a different class. But if we come over to this one and we look at it, we go, there are a bunch of different ways. There might be factory connections that are made similar to how a Molex is made. But when we're making them, we're going to be using the double crimping device and those tools. So this one, double crimped, but why can't we use that in aviation? Forked, yeah, it's open on the end. It's hard to see from your end, another forked one. Almost all of these are going to be not acceptable for one reason or another. But this guy basically just has heat shrink back over him when he's done. That always looks really nice, and it's kind of cool. There's some different parts that talk about if our wires are going through a hole that's within, I believe it was 3/8 of an inch when we went through that part. I think we can talk about it more when we come up. There's supposed to be a grommet on there to protect it electrically on the hole. So there's a little small piece of heat shrink, looks really nice, but now I can't see my connection. Now I can't see the wires. If they're starting to get hot under there, I don't know, probably not going to see it. That heat shrink can take a lot of heat, so it's not gonna tattle on it. So even though they look beautiful with heat shrink, one of those preference areas, we'd actually rather leave them raw so that we can actually see what's going on, make sure our wires aren't getting busted. The one advantage to having heat shrink is it does, if you leave a long enough piece of heat shrink on there, it does shrink down onto the insulation. and gives you a little bit more strength in the whole joint, right? But other than that, we should not be so close to other terminals that we need it on there for the insulation anyway. So it's down to, it's kind of for looks, kind of helps with our insulation, but there's gonna be some preferences there of why did you heat shrink that? And if you remember, oversize 10, we're doing non-insulated anyway, and they just say, hey, non-insulated. Make sure you're using the right size terminal. I was trying to hunt around and find a good spot that lists them. This one came up for me. Red is for 22 to 16 gauge. Blue is for 16 to 14. Yellow is for 12 to 10. What you'll notice is a catch 16 in both of those. Depending on the chart you're at, sometimes you can get some overlap. Whoever has the tool, it'd be interesting to see what it says. But we don't want to just put a really small wire in a really big terminal. So if I went to this little wire here, cut it, I didn't even read, what gauge is that stuff? It's 20 something, 22 gauge. All the way down, I don't even know if this stripper goes down to 22 gauge. Oh, it's gonna be a little difficult. I might need a different wire stripper. I don't want to take my 22 gauge wire there. It's just the insulation, not the wire, it's okay. And say, you know, I ran out of red terminals, but if I put them in there, I can crimp it down far enough, right? It might hold. Let's see. Feeling weak today. Hey, it's in there, right? That's a good connection. But the issue is when I go to test your terminal, oh man, this stuff is Teflon coated. It's the good wire. You can't get a grip on it. When you go to test it, a lot of times you can pull it right out. Now, this one made a liar of me because I happened, man, did I pinch that guy perfect right in between the middle. But you don't want to do that. You want to go down to the correct size for the wire you're using. Now there is one exception to that, especially when you're using really small wires like this 22, or you might even have 24, 28 gauge if you're working in airline stuff, is even the smallest of connections, like the red ones, this wire is going to be very loose inside of there, right? So on very, very small ones, what happens to make sure that the crimp is tight on there is if you fold it over, give it a loop, and then put the loop in. Basically, you're not doing it so that you have a better electrical connection, and that one's so close it's hard to get in, but you're doing it so that it fills up more of the barrel. Bad example, you gotta fight with them to get it. I think I would need one size smaller wire to make that work out. There we go. But you can fold that over on itself and put it in there and crimp it over. It basically fills more of the barrel to make sure that it's in there. What you don't want to do is you don't want to fold it over so that it's folded all the way to the edge of the insulation and then crimp partially insulation, partially wire. You want to make sure that it's folded on itself, because our crimpers are going to crimp in two spots. We're going to have one crimp on the wire, and then we'll have the second crimp on the insulation itself. So with really, really tiny wire, that's a trick. You fold it over on itself. But that even stresses kind of the bend, so it's more of a filling the barrel than it is a electrical piece. I think I put that on that one there. So you get kind of a view of what we're doing there. If I had a wire and I had a yellow connector, would I want to fold this one over to fill up that barrel? No. At that point, I I go get the smaller barrel, right? Go buy it, go find it, do what I gotta do. That folded over is only for the red, for the really tiny stuff where we're like, well, we don't really make a smaller than a red. I haven't seen them. Somebody's gonna be like, I saw one once. I'm like, I don't think so. I think red is as small as it gets. All right, larger than 10, we said we use non-insulated connectors. I went and I grabbed this, out of the shop. Ooh, that's pretty cool. You could really pinch somebody's finger with that. Zoomed in on it, and you'll want to probably look at this later. There's little numbers. We'll try it on the screen, but I don't think it's going to work. There's little numbers. Oh, there you go. You see the 2s? So that's for 2 gauge. So if I push the button on the back, I can rotate that, and I can switch it to whatever gauge I need. I believe 8, 4, that's interesting. I get like 4 and an 8, where's my 6? There's a 6. Okay, 6. We're gonna get it there, because I'm looking to use up some of Smat's money. Is that the same? I don't know if that's the right, that's not the right one. Let me get it there. Almost there. Oh. All right. There we go. All right, so sanity check. It's the number up towards the tip. So if you were where I was, 6 is up top, and 2 is way down in the bottom here where you can barely see it. So we're using the number up top. So that should be the one for 6 gauge. We'll do this and then we'll take a little break. I bet this doesn't go up to 6 gauge, huh? 8 gauge. So if I try to use that on this, I'm probably gonna cut through my insulation. So go find a bigger one, grab a knife, do it carefully. I don't wanna spend all that time, so we're not gonna put this on an airplane. Everybody okay with that? This isn't going on an airplane. We're gonna see what happens. If we go to 8, be really careful. I don't have my razor blade up here either. Close. Of course, I had to grab the braided stuff. That's not plastic. Getting it. Getting it. There we go. Oh, he had his knife. There you go. All right, this stuff looks like it's stainless steel wire, but just for review, oh, you guys can't tell. Is this stainless steel? What do you think? No, it's going to be a copper with a coating. If I look on the end of it, I can see the copper coating. So just a little review there. Uh-oh. I cut through some wires, bad connection. I'd have to do that again. So we're pointing out, that's why you use the correct stripper for that. Okay, let's get them in here. We'll get it on there. Number 6. Sometimes it's nice to have a buddy for this. You can be my buddy. Okay. Now, I believe I have it on my slide. Oh, I might have missed. I believe I have it on the next slide. Or coming up. There it is on the back side. It'll say the AWG wire on it. Number 6. And it'll actually say our number of crimps and everything. Somehow we did something wrong here. And it's not getting tight on us. Might be because I cut those ones out. Or maybe I'm not 6 gauge wire. That could be 8 gauge wire. I bet that's what we did. Because that's not. Alright, so what's one of our rules in aviation of every wire should be labeled, right? And I grabbed one that wasn't. Alright. So anyway, we'll leave that up there. You get the idea. Use the right size wire. It's like like the boom guy on electrical or everything wrong. Oh, look at that, demo tool on 8 gauge. Alright, lead. Aluminum is only used for 6 or larger. I'll do this one, don't take a break. 6 and larger, meaning 6, 4, 2, 0, 00. So we don't want to use 6, or we don't want to use aluminum wires on smaller than 6. That question likes to pop up, and I couldn't think of anything to memorize to remember it, but it pops up various places, and they want you to know that. There's one other one that I just put really big, is they use it on 6, and generally, if you go in your aluminum chart, wire sizing chart, aluminum wire is 2 gauges larger wire. So if you had a 8 gauge copper wire and you wanted to replace it with an aluminum wire, you'd put in a 6 gauge aluminum wire. If you had a 10, let's see, we gotta go bigger. If you had a 4 gauge copper wire, you'd put in a 2 gauge aluminum wire. So generally, they like to ask that question of, if you're replacing a copper wire with an aluminum wire, what do you do? And the general answer is, you go 2 gauges larger. And then they throw a caveat on there to like get you like with a gotcha question on the written. And, but not always. So, I hate it when they do that. So I wanted to point that out in big letters, so when you're taking the test. All right, take a 10-minute break, come on back at 8 o'clock. Man, that's what happens when it's 6:45 in the morning. You're going from memory on. What size wire is that? Definitely not labeled. Well. This would be a good one for measuring. What size it is though? You'd have to measure 1, count to like 50. Ooh, make sure quarter mils.
How many is in there? There are a bunch in there.
I bet there's at least 50.
Oh, wow.
Well, 45 now. I'm not sure how I make this lesson much more exciting, Gavin.
Yeah, I don't know how you do that either. It's just current, Ben.
Took a current up to white current.
That's just a bad idea.
Probably ones like these, you're tempted to just make it really short and not teach it. You're like, no, we gotta teach through it, especially for people that haven't been electrical. Ooh,
Am I not allowed to use these?
you are allowed to use them, but it's highly, highly not recommended. So, from Kirk's class, what would they call this versus the FARs? Yeah, acceptable, not necessarily, what's the word that the FARs are? Approved is more like service manual. FARs are law, and this is
Not law.
acceptable. It's recommended to use these style instead of that one. If you're using these, what you're gonna wanna be careful of because, well, it's got a double on there, it's a good one. What you're gonna wanna be careful of is to make sure that you get it crimped in both spots. So you come on there and you're gonna crimp it on the wire itself, and then you're gonna back up and you're gonna give it another crimp across the barrel and the insulation. So that's gonna be the biggest thing is on these ones, you're gonna be tempted to not do both crimps. That was kind of the wrong size wire. Where you look at how wide that is compared to how wide yours is. So this literally has, and you're looking at it, it's 2 different spots it's crimping it. So if you're using those, just make sure that you get both when you hit both spots. And then the other one on those ones, you notice there's the bare and the, all our small stuff is not gonna be bare.
Okay.
It's gonna be insulated, so you're pretty much only gonna use the insulated one.
Should be right there.
Yeah.
So is it,
connection with these. So what happens with those is, once you get good at it, you get used to how tight do I gotta be, where this guy automatically does it for you. So, yeah, and that's part of, you get into, there's a bunch of different styles of connections, right? So as long as your connector is stronger than the wire, good luck. As long as it meets the criteria, it's a good connection.
Okay.
So then it's, well, how do we make sure every one we do is a good connection? And they're saying, you should use this.
Okay. So you're just crimping down one right here, and then one going over the insulation.
Here, I wonder what's wrong with this thing. It's kind of bugging me to, it's cutting through my wires. We might be able to adjust that bottom jaw. That shouldn't be happening, because I keep cutting all my wires off. So what we want to do if we trim it the right length is we actually want, I probably just cut it too long as part of it, but I actually want one of the jaws, so like the bottom one if you will, to, when we're all said and done, to be on top of the insulation piece. So basically, one of my crimps caught just wire, and one of my crimps caught insulation and wire, and that gives us a little strength. So obviously, I stuck it in there too far to do it, but that's where we're saying, hey, I want it to be on both pieces, not just the wire one. And with those ones, it's gonna be pretty easy to do just the wire. But even with these, you gotta be a little bit careful, because you're going, hey, how far did I put it in there? I don't wanna go too far. So there's a piece of, how far you strip it's pretty key.
So would there actually be a little bit more, you can actually make a little bit more decisions with this than that?
That's kinda how you'd phrase it that way,
Yeah.
is you have to. This one, it's
Which
almost
could be
impossible to
better.
do wrong. With those ones, well, you could not have it tight enough. And so with this one, every joint's gonna be the same. It's gonna be the same every time I go, because it gets to that spot, and it basically it bottoms out on itself. With that one, it's only a pressure. So it's kinda like, this is torquing a bolt, that is going hand tight. And going, I think I'm in the neighborhood. So, yeah.
Color here is, what does it mean? Is that what it is?
Yeah, so if I have a red connection, I'm gonna go in the red one.
Oh,
If I got a blue connection, I'm gonna go in the blue one,
okay.
and a yellow will go in the yellow. And they're getting bigger as they go. So the red ones are the smallest, the blue ones are the next biggest, the yellow are the largest. If we get beyond yellow, we're gonna be into the uninsulated, and we're gonna go to more like one of these guys.
So the point where the hole is always face the color?
It actually doesn't matter. I was looking on these, and there was one of them, one time I used, that the side that crimped down onto the wire insulation was a slightly larger hole. And now I've been looking at all of them, and I can't find it. I don't know where that thing went. So it actually doesn't matter which way you are. It's both the same crimp side on almost all of them. One of these days I'll stumble across that one.
I've never used a directional one.
It must have been just an oddball I grabbed. It was just ever so slightly different on the one side.
I just wonder, the connection with the fork,
Yeah.
where you usually use in the airplane that with the fork? Yeah,
This here?
Yeah.
We don't. That's what I'm saying. No,
Okay.
never. No, never. Let's see. This one, sometimes, this is better,
Okay.
but when there's a lot of wire connections, like on the back of a switch, sometimes it's too hard to get to all the screws, so they'll put this style in. So sometimes, best, never.
It means that one we can use for other automobile
Yeah.
parts. Okay. Yeah.
Yeah, this is used a lot, automobiles, houses, industry, stuff like that. But quick slide in about 4 slides, but we're not taking it. We just didn't quite make it to our break. Shouldn't be too much longer. I'm gonna say less than a half hour, and then we'll head out to lab. So that's good news. Falling objects are a hazard. They're a big hazard. When we say falling objects, if you're behind an electrical panel and you're working somewhere and you drop a washer down back behind here with all these circuit breakers, you better find that washer. You will find that washer because it can short across terminals. That'd be a big bad problem. Papua New Guinea, one of our mechanics was taking a radio out, and he thought he dropped a little, it was like a 1/2 inch by 3 inch aluminum piece that was a spacer on the radio, and he spent about 4 hours, and then the other mechanic spent 2 hours, and I spent 3 hours. We could not find that, and I think what they ended up determining was, you know what, I actually didn't have the spacer on this airplane, that was the other one. But we spent 7 hours looking for a little piece of aluminum that turns out we think was just a memory trip that last time he worked on the other airplane it had one. And we all have the same airplane, so it, you know, when you're in the cockpit, well, it can happen. But that's how serious it was. We didn't go a half hour and go, it must not be in there. We literally spent 7 hours looking for the thing. Tore the panels off, it got crazy. It's that big of a deal, and we're glad we did it. Because it would be terrible to have something electrically shorting out across that stuff. So that's obvious when it's circuit breakers. You gotta be really careful with other components, if there's anything above electrical components. One thing that we talked about previously, but especially with wire bundles, if you're doing any sort of drilling above that, maybe you're doing a sheet metal patch repair up here. If you're drilling, if you're doing stuff up here, the metal shavings can fall down into there, and then they get in between the bundle, and as that bundle moves and vibrates, it can wear its way through the insulation. So whether it's a washer that dropped down that we want to make sure is not stuck in there, or a screw, or just metal shavings from riveting, we want to be really careful. So if we're going to drill into an aircraft, we're typically going to put a blanket, put something over our wiring that's down below there, so that we don't drop any especially conductive material down onto terminals and or wire bundles. We want to go really far to protect that. For that reason, we use junction boxes for stuff. Now this junction box is because we've got essentially a computer board in there doing stuff, and we've got wires coming from one place going to the board, and they all go out to the other one. So sometimes our junction boxes are for that kind of situation, and we're going to talk about our connections to those in a later class, so I'm not going to spend a lot of time on them now. But I had to put something about our junction boxes in the lecture at one point. The word oil canning is if we just had a flat surface on, say, the cover of this junction box, or the back side is another spot. If it was just a flat surface, as it warms and cools, stuff like that, it can pop one way, then pop the other way, pop one way, then pop the other way, and that movement can be very bad. I'm not sure it's that actually big of a deal. Maybe it's just the manufacturers have figured it in, but the written test, you'll probably all get that question on there, is they'll want it, they'll either call it cross broke, or in the convex or concave position, so you don't get oil canning in that junction box. We don't want them popping in and out. I don't know why they emphasize that so much. Does that make sense though? Cool. If the junction box is in a hot area or supposed to protect in case of fire, it's going to be a stainless steel box. That'll come up a lot of times. Firewalls in aircraft are often stainless steel because it's a firewall. So our junction boxes are the same idea. If it's an area that's supposed to protect the wires or connections in case of a fire, it'll be a stainless steel box.
Jason, can you explain the oil can thing one more time, please?
Yeah. Let's say this was a electrical box and we were making connections in here. Right now when it heats, close enough. Right now when it heats and cools, this bottom piece could that's a battery box, so it doesn't have the cross brace. Yeah. I don't know. That was, it's on the written. Theoretically, if your wires are inside while it's doing that, you've got a friction or movement area that can rub on the wires. The other part is if you oil can enough, you'll weaken the metal, and the metal itself can fail. That's my best explanation, but I have to pull this info from like 5 different places. It's your book, it's the FAA written, it's the O's and P's, and I think 3 out of 5 have this in it. So I'm like, well, better teach them oil canning, so that when you get that question, you don't go, Case never taught us that. Well, now I got it. Oops, sorry. All right, we talked about this previously. Hopefully nobody gets these wrong on the exams. They will be on the exams, the midterm, your exam, your written. No more than 4 terminal lugs or 3 terminal lugs, and the bus bar should be connected to any one stud. So the number is 4, but every once in a while they'll try to get tricky on you and say, let's say we got the back of strip like this. Now that'd be a bad example because it's just connecting, but similar example. So our bus bar, say it's a bus bar, the bus itself is going to count as 1 connection, and then you go up from there. So that's how they're labeling that with it's 4 connections or 3 in a bus bar. Does that make sense, everybody? Cool. Figure if I repeat it enough, everybody gets it good. No washers between the terminals is the other part. So if you notice in the images, we don't have washers in between our terminals. So don't be thinking, oh, I need washers in between those. The washers go in the real specific positions. You can find this in AC 43, you can find it in your textbook, and most of the time we're going to be tin copper connections, which means we might have an aluminum alloy washer on 1 or 2 of them. Usually it's just between the structure and our bolts. But the actual electrical connections typically are the tinned. But no washers between our terminals. Our terminals press to each other. And it needs to be a locking. So we talked about that previous as well. But it needs to be a lock nut on the end of there. More locking mechanism. What we're not counting on, and we're assuming is not an electrical connection, is if I was to draw that bolt going through the piece of aluminum, we're not considering that surface area to be our electrical connection. You're not saying, oh, I've got electrical connection going through my bolt is part of my connector. No, we're not counting that. We're counting that surface area as the electrical connection on these. So the bolt is not supposed to be considered the electrical connection. It's the mating area, so theoretically you'd say it's that connection between those 2, that one between the washers, between the washer and the nut, and those 2 there. That's our electrical connection, not the bolt going through the middle. Everybody follow me with that one? Cool. Instead of a locking nut, they do allow you, and that's why I use the word locking mechanism. If you have 1 nut and then you tighten another nut onto that, it basically jams the threads. That is considered a locking mechanism, so that's why it says held together with 2 nuts. Yeah, probably going to depend on where you're at, the manufacturer, what they got going. If they're using a lock nut or if they're using 2 locking nuts. On the 206, all the landing gear, they use 2 nuts. So, for what it's worth. These guys, quick review, are always going to be so that if I was to pull on the wire, they'll have stops so that I can't pull it loose, whatever one's connected to the nut or touching the nut. So if I pull it, That's gonna be tightening that nut. So all those, and you can go through on your own if you want and look through them and say, oh, okay, yep, so if I were to have any wire movement relative to the stop, it actually tighten the nut, not loosen it. Does that mean we can have movement? No, that's not the idea. The idea is it's a locking force so that there is no movement. Leo? There is, yeah. There's always one. No, so what it is that's not touching the nut. It's underneath the nut. This one is the one that's on the nut. So the one that's touching the nut is locked out. The one underneath there, that's not really the one that's gonna loosen. If I were to move this, that's not good, but that wouldn't loosen my nut up. If I move this one, because the surface is mating on the nut, it loosened the nut up. So exactly the point we're making, good question, good observation. The one touching the nut, and then technically you're like, well, is the one touching the washer touching the nut? Because there's usually a washer between. Oh, I was a slide ahead. Studs should be anchored against rotation when more than 4 terminals are to be connected together. Oh, that's kind of cool. I read it really fast the other day. If you got more than 4, they're saying use 2 studs. So that's back to the only 4 per stud. Current should be carried by the terminal contact surfaces and not the stud itself. So that was what I was saying when I was drawing that out. Highly recommend, and I talked about this earlier, but maybe taking a note, reading those 2 pages in your book or that in AC 43, just solidify what we're going over today when you get a chance. That's the break we're skipping, so we don't have that many slides left. All right, wire bundles should be above flammable fluids. 6 inches is what they like to use for a distance. But above, below, the whole idea is if my flammable fluid line leaks, I don't want it dripping onto the wiring. That's the idea. I was looking for a good picture that had flammable fluids and wires, and I know I've seen them somewhere where the wires are like 6 inches above it. When I made the slideshow, I couldn't for the life of me figure out where it's at. So I threw this one up. Mostly wires, some flammable fluids. But electrical wires should be above your flammable fluids. Let's say you got a damaged wire in there and you're thinking about splicing it. 992, and I actually say let's look in the book. So why don't you go to your book, 992. It is pretty insistent on, we don't like splices, we hate splices. I talked to you guys once about in the front of the service manual for each aircraft, on almost all the modern ones, you'll actually, if you dig deep enough, you'll find a section that'll either say we allow splices or we don't allow splices. They go that far, but your book, the way they phrased it, says damaged aluminum wire must not be temporarily spliced. That's interesting. So you damage an aluminum wire, you're out of luck, Jack.
Temporary emergency.
Yeah, so temporary emergency splice is how they like to phrase it. So if you have a copper wire, okay, we can do a temporary emergency splice on our copper wire, which what that would mean is temporary. But go to the service manual if you really want to have the long-term details. So when you read through there, it's pretty insistent on temporary. If you go in AC 43, which is where they get it from, splicing electrical wires should be kept to a minimum and avoided entirely in locations subject to extreme vibrations. Splicing of power wires, coax cables, multiplex buses, large gauge wire must have approved data. So if it's a big wire, they're saying, okay, well, show us where you got the information to splice it. Most of the time in AC 43, they don't say, if you have approved data, you can do it. I'm going to phrase actually going one step further here and saying, look, if you're gonna splice now the funny part is, what does large gauge mean? We gotta get a dictionary out. My avionics guy, and I got a like 14, is like, man, this is a large wire. Point being, both sections are very specific about they don't like splices. If there's a splice though, there should not be more than one splice in any wire. So if you got a connection in the nose of the plane, a connection in the tail of the plane, only one splice in that section. Part of why they don't like splices is for that reason. What if Bob put a splice in 3 foot in front of you on the other side of the bulkhead, and you put a splice behind the bulkhead, and we're up to 2, and neither of you put notes that say, I already got a splice in this wire, so they say, just don't do it. But you can, they call it emergency, between 2 terminals, 1 splice. If you're gonna splice it, and you're gonna say, I'm splicing it anyway, so you're flying, and you're in war, and they shoot shrapnel at you, and you gotta fix those, I don't know, I can't think of why they like it. You don't put the splices all stacked on top of each other, you stagger them. So, I'm spending time on this, we already did, because it is a written question that you will have. So just know it, you'll have the question, and you'll say, yeah, he taught us ad nauseum. All right, back to bend radius. You guys, I thought you had a sheet metal class. You guys haven't had sheet metal class yet. Okay. You'll do. Oh, I hate bend radiuses. That's why I'm not a sheet metal guy. Bend radiuses is really what it comes down to. Good artists, they like bend radiuses. They do the math. It's fun. You'll measure this piece of aluminum, if it's a piece of aluminum, and you'll say, well, it's going to stretch this much, and it's really cool if you like that kind of thing. And I don't. But bend radius is the radius of the circle that if you were to put it inside there, meets that bend. If I had a circle that was this big, you can see it doesn't touch the whole radius. So if this one is 6-inch bend radius, that one I just drew would be a 4-inch bend radius, and you get the idea on that. So bend radius should not be smaller than 10 times the largest wire in the bundle. Now that's if it's in a bundle. They do kind of stick with that 10 number, so if you're only going to memorize one number, the 10 number is a good number to memorize. But they start with 10, and then they start this list of exceptions for you. So 10 times the bend radius of the largest wire in the bundle. If it's not in a bundle, they still tend to stick with the 10. There's a trick question on the writtens and maybe on your exam that one of the answers says 10 times the diameter of the bundle. That would be incorrect. It's 10 times the diameter of the largest wire in the bundle. Gets tricky on some of them the way they phrase it. All right. Bundles exiting or reversing from another bundle. Now this isn't a bundle exiting, but if you imagined I had 4 wires that came out of this bundle and they're going to head somewhere, I guess this one would be that kind of idea. They'll give you 6 times the largest wire diameter. So basically they're saying, if we have a breakout section, we'll let you, instead of being 10, we'll let you be 6. And then they'll say, hey, if it's an individual wire, if it's supported, we'll let you go down to 3. So they're basically, 3 is pretty tight. I mean, if I was going to measure the diameter like this, that's pretty tight. So 3 on this guy is going to be probably in this neighborhood. Pretty tight. I don't have a measuring device on me. But what they're saying basically is if my bundle's coming through here, if I'm going to go all the way down to 3, they're not going to say all the way down to 3 and I'm just connecting to whatever terminal I am, because essentially what's happening there is I've got some stress built up in both my wire and my insulation that's trying to spring me back open. So they say if I'm supported, so clamped around the wire, not counting the terminal on the end, if I'm supported somewhere, I can go down as small as 3 times the diameter on an individual wire. If it's not supported, you end up with typically the 6 or all the way back up to 10. Where that gets important is when you get in a really tight area. These guys are probably well over 10. Did it have any tight ones on there?
Big yellow one.
Oh, this one here. Maybe that's what I was looking at. That guy's getting pretty tight. Is he supported? Nah. So that's probably less than 10 unsupported. So what they probably should have done is open them up a little bit more and then put them under here. What's the other reason I don't like that drawing? Cable ties. Yeah, Parker.
So like realistically, how do you measure all that?
Yeah. You're gonna grab a caliper, like you're using to measure metal stuff. You're gonna measure the outside diameter of your wire. So let's say this is my wire and my outside measures at 1/16 of an inch. When I make a bend with that wire, now that's my diameter. So I'm gonna take my 1/16, I'm gonna multiply it by 10/16, and my circle has to be 10/16 of an inch. 10/16 isn't that big, we're still less than an inch. This thing is the radius, excuse me. The radius is probably a 1/4 inch on here. So I think I would say you'd have to get a round thing like this, that's the right size, but the reality is, just to point out, if you get one that's bent that tight, I'm probably too small. You want them to be sweeping. If you're looking really close, once you get down to that, the insulation will typically start to get where it's getting to where it's almost deformed, and that's what we're worried about, is our insulation and our wire getting to where they're deformed and we're kinking it. But yeah, if you were actually gonna measure that bad boy, you'd have to measure the radius, not the diameter, of a round device, and you'd have to be like, can I fit that inside there? So like, if that was all measured up, that one doesn't fit, so that would be too tight, if I did all the measuring.
Include the insulation technically on the wire?
Oh yeah, oh yeah. Yep, because the insulation's half what we're worried about. Wires should not be pulled tight like a guitar string, I like to put it that way. I think they phrase it a different way, but they don't want them super tight so there's tension on the wire, but they also don't want more than that 1/2 inch maximum drop. So this here, that's more than a 1/2 inch drop with a little bit of hand pressure, because it's already loose to begin with. So that 1/2 inch will show up on various tests. Part of that is, if this was in an aircraft, as sloppy as that is, and we're flying around and I'm hitting bumps, and it's a bunch of bad landings from case, and we're on the water, those wires are gonna be not only possibly hitting stuff down below, but all that slopping around puts a lot of stress on where the clamps are. So if they're somewhat, I probably can't pull that. If they're somewhat straight, you don't have that force and the acceleration force, so when you're bouncing around, it's not gonna be near as much stress on the end of that thing. So 1/2 inch maximum, but not tight like a guitar string. Is that making sense to everybody? Good. This is not typical in aviation. You might find it in some places, but when we use the word conduit, usually what we mean is something like this. Flexible shielding for our wires. So this took me the longest time. Every time I read conduit when we were talking about electrical, I'm thinking this, because that's the world I come from. But your brain should run to this a lot faster. It's a flexible connector. This would be very heavy, and it doesn't flex with our aircraft movements, right? This stuff flexes with our aircraft movements. What we're worried about is protecting the wire more than we are supporting the wire. So this is what you should think of when you think of conduit, even though there might be a very few occasions you get a hard one. If you're having trouble pulling your wire through conduit, and hopefully your mind runs to this, not this, Powdered soapstone is what you do. You don't put soap on it. You don't put the liquid stuff that the electrical guys do, because we don't want any liquids sitting on our wires for the next 80 years. So a powdered soapstone is what we use to basically make our wires slippery to pull them through. One of the other reasons we don't do this much in aviation is our next slide. Anytime we have a spot where if liquids got in there, now whether that's from I'm flying at sea level, then I'm flying at 40,000 foot and everything got cold, and then I'm at sea level again, and then 40,000 foot and back and forth, and if there's condensation or not, we need a hole at the bottom of any bend we have for moisture to get out of our conduit. I don't know the answer to this one, I'm gonna admit. I believe these are gonna be considered not watertight, so it's not like there's gonna be holes in most of these. But when you see this picture, it gets awkward because this kinda looks like it's a flexible part. What they did spell out is they called this one tubing as opposed to flexible conduit. So one of the things they want is if we have our wires run through, and this gets spelled out a lot, I think I hit it on some slides later, if we're going through a wheel well area, anywhere like that, but wheel wells specifically will show up on tests, we need to have our wires in a conduit, have it protected. If what it's in is a watertight, because if we're in a landing gear area, sometimes we don't want all that water spraying on it. You want to make sure you have that hole for the water to be able to get out at the lowest point. Four more slides-ish. Clamps. We're going to be supported. Remember, zip ties, cable ties are not considered support. You don't get to zip tie your wires to something and say, hey, I'm supported. That's one of the biggest temptations if you go down that road of using cable ties instead of lacing, is to say, oh, no problem, we'll just tie it to that structure right there. Not considered support. We want to use clamps, and it's unbonded clamps. Remember, bonded clamps are ones that don't have any rubber or plastic on them. So it's a little bit ironic to use the word unbonded, but maybe we should say clamps with rubber, but we use unbonded clamps, meaning clamps with rubber. And we don't ever want our wires to go more than 24 inches without being supported and or secured with a clamp. They have some ways they don't like these, and I'll admit when I was making this, I was looking at this slide, and Leo, tell me which one you think is fine that they don't think is fine. Anybody else? This here and this here? Yeah. I had the hardest time for the longest time trying to figure out why they like that. Fairly obvious, these ones, what we don't like is we could have wires falling down in there and getting pinched, right? There's a slide later on, maybe I didn't put it in there, that shows it. So I went back to this. The reason they like these ones is the clamp itself is not gravity trying to pull itself away from the bolt. So if you look at this one that they don't like, the clamp itself is trying to pull itself down and away from the structure, and it's hanging on the bolt. That's why they don't like that one, and that's why they don't like that one. Notice on here, the wiring, it's kind of pulling you off because you're on the bottom of the structure, but it's not trying to fold itself back over the bolt. So it's kind of splitting hairs on that. But the weight of the clamp on these, gravity is going to tend to hold it in the same spot, where the weight of the clamp on these, gravity is going to tend to try to twist it around the wire, and we don't want that to be twisted around the wire. So that's why they call those ones dangerous and these ones okay, is the weight of our wire running through there is going to tend to keep it in the same position, not tend to want to spin it around. Make sense? that's why this one's like, really? I'm not gonna answer it 'cause I'm being recorded. But, the reasoning is they don't want the weight of it pulling it around. So, yeah, I don't believe you'll find it forbidden. They do like brackets, and there'll be a bunch of ones that you'll see where, you can put a bracket on there to get it, supported, and notice, they put them up on top of the clamp, not on the bottom of the clamp when they're connecting it to it. And then they give you some typical mounting with the way the washers are. They don't want the lock washer biting into the structure. That's the main thing that we're gonna point out, is they don't want that lock washer to be biting into our structure and causing damage. Oh, there's the picture. It's got a wire snuck in between there and it's biting our wire. All right, here's the 3/8 clearance. If you're going through a hole and you have more than 3/8 between our metal edge and our wire bundle, you're fine, just run it right through the hole. If it's less than 3/8 from the edge of our wire to here, now if I drew this end on, that might make more sense. So 3/8 of an inch between our bundle and the metal. If it's less than 3/8, we need to put a rubber or other grommet in there to protect it. I don't know if you'd say vibration, but maybe the clamp gets loose, that kind of idea. So they've got a couple different styles they put on there, but 3/8 is the magic number for those. That one might get you on your projects. Remember, your projects have to be airworthy. So if you're running wires through holes, if they're metal, well, how are we gonna run the wire through that? So try to make sure the wire is big enough, or sorry, the hole is big enough, or that it's protected with a grommet. Most of your wires aren't gonna go through holes, but pay close attention to that while you're doing it. Yeah.
That rolls for the same and single line?
Yeah, yep, same 3/8, yep. All right, this one was one I just didn't know where to put it in. We'll probably touch on it a couple times later as well. If I've got current, they said plus and minus, but if I've got current flowing one direction in this wire and another direction in that wire, I can set up magnetic fields that interact with each other, right? They're gonna wanna fight, and you can do the whole, let's see, if I got it flowing one way in this one, it's coming at me, my curl goes that way. If it's going this way, my curl's going the same, and they'll want to interact. So that's one thing they're looking at, but the other one is what's here. So I might have just confused you on that. This one shows if I've got a positive charge and a negative charge. So we're not talking current, we're talking, this is on my positive lead on the battery, and this is on the negative lead on the battery. They can actually set up a dielectric field, and that wire will act like a capacitor. And it gets a little bit weird that way. Mostly that's gonna be if we're talking communications and really small electronic stuff. We gotta be worried about that kind of stuff. But they'll call it capacitive action, and crosstalk is, it's hard to read that, but crosstalk is the word they use for capacitive action. We don't actually have electrons jumping through, but because one's positive, one's negative, and there's a dielectric field there, if they're in very close proximity, you can have what they call crosstalk, and we don't like crosstalk. So a lot of times they'll either be shielded or they'll try to keep the wires a little bit further away, but they want you to know that term, and that's going to come up more in avionics world, which we're not dealing with. Whew, made it. Any questions? Okay, I have my list, I think, actually, do I have my list? I think I got through everybody that was on my list yesterday, in the afternoon yesterday. So, if you need me, if you need to get on the list, come let me know. But otherwise, you've got your projects to work on, and you have all those lab uptell the projects that you can be chipping away at. Dismissed.